Okay, we're going to go over the Chapter 4-5 test today, which covered Chapters 4 and Chapters 5. The first few questions are from Chapter 5, and then the last few questions were from Chapter 4. The first question was 1/7 squared. All right, so anything squared means that number multiplied by itself twice. So that's going to be 1/7 times 1/7. And when you multiply fractions, you multiply across. 1 times 1 is 1, and 7 times 7 is 49. Now, since your question was asked in the form of a fraction, we would want our answer in the form of a fraction. So that would be the correct answer. If you happen to use your calculator and you did the fraction 1/7 squared, you see you could check, it would also say 1/49. If you came up with 1/7 squared, you came up with this decimal, you would want to convert to fraction to get 1/49. All right, so the answer to the first question is 1/49. Now the second question is -7 times y to the 0. -7 times y to the 0. Is the -7 being raised to the 0? No, it is not. Just the y is being raised to the 0. And anything to the 0 power is 1. So this is like -7 times 1. And -7 times 1 is -7. All right, so you have to remember that anything to the 0 power is 1. And just this variable was being raised to the 0 power. And if you're looking at your order of operations, you do parens, then exponents, then division and multiplication from left to right, then addition and subtraction from left to right. So we don't have any parens in our problem, but see how the exponent is a higher order operation than multiplication? That means we would do this exponent before we did this multiplication. So that answer is -7. Okay, for number 3 here, we have -4 raised to the -2. So when you have a negative exponent, you can change that into a positive exponent by putting whatever is being raised to the negative exponent down into the denominator. So -4 raised to the -2 is the same as 1/4 raised to the +2. This has a negative exponent, this has a positive exponent because it's in the denominator. And -4 to the -2, everything in the parens is squared, which means that is the same as -4 multiplied by itself twice. -4 squared is -4 times -4. Now a negative times a negative is positive. And that's your answer. So again, if you're on a calculator and you say -4, that being raised to the -2, notice you're going to wind up with a decimal. If we want to put that in fraction form, that's a positive number, 1/16. So that's the first page of the test. Let's look at some material from Chapter 4, which is solving systems of equations. This first question said to solve the system using the substitution method. We want to make sure you know both the substitution method and the addition method. So this problem was insisting that you use the substitution method. And this problem is set up beautifully for the substitution method because we have one equation, 5x plus 4y equals negative 22, and x equals negative 3y. Those parens say that this is a system, meaning we're looking for a solution, a value for x and y that will make both equations true at the same time. And the substitution method says take one of the equations and substitute the other equation back in. So this is already set up for x is equal to negative 3y. That means I'm going to substitute in the first equation. Everywhere I see an x, I'm not going to put x. I'm going to substitute negative 3y. So bring down the 5, bring down the, bring down the 5, and we're not going to put x. We're going to put negative 3y. Let me make sure this is clear. We're not going to put x. We're going to substitute. Oh my goodness, I want to do it a second time. All right, I am not going to put x. I'm going to put what x is equal to. Negative 3y. I'm going to substitute everywhere I see an x. Negative 3y. Now bring down the plus, bring down the 4, bring down the y, bring down the equals, bring down the negative, and the 22. So how does that help me? Now I have an equation that isn't a single variable. It has just y's. So let's distribute. 5 times negative 3y is negative 15y plus 4y equals negative 22. And we want to solve for y. We want to end with y equals. Well, negative 15 and positive 4, opposite signs, you subtract and keep the sign of the greater. 15 minus 4 is 11. And the 15 was a bigger number, so that's why we're using the negative sign. Or you could do negative 15 plus 4 in your calculator. Bring down your equals and bring down your negative 22. And we want to get y by itself. So right now it's being multiplied by negative 11. To undo that, we're going to divide both sides of the equal sign by negative 11. A negative divided by a negative is positive. Or you can do it on your calculator. Negative 22 divided by negative 11 is 2. So I'm not done. I know the value for y, but to solve this system, I need a value for x and y. So now I'm going to go back to this equation. I have this really nice equation here that will give me the value of x if I know the value of y. So let me write that down here. X is equal to negative 3y. In other words, x is equal to negative 3 times 2, or x is equal to negative 6. So you could answer x is negative 6, y is 2, and put a box around it like that. But the shorthand notation for a value for x and a value for y is ordered pair. Negative 6, 2. And so that would be your answer. And if you wanted to check your answer, just to make sure you're right, 5 times x plus 4 times y should equal negative 22. Here's that equation. I'm going to plug in x is negative 6 and y is 2. If this is the correct answer, this should be a true statement. 5 times negative 6 is negative 30, and 4 times 2 is 8. Does that equal negative 22? Negative 30 plus 8, opposite signs you subtract. Keep the sign of the greater. Does negative 22 equal negative 22? Yes, it does. That's my check that my answer is correct. And at this point in your career, you should always check your answers, because if you did not get a true statement, you would know you did not have the right answer, and you'd want to go back and find your own mistake. If you find your own mistake, it doesn't cost you any points. If the teacher or my math lab finds your mistakes, then it actually costs you points. All right, so that was number 4. That was an example of the substitution method. Let's move on to number 5. Here is another system of equations, but here they're explicitly telling us that they want us to use the addition method. So I'll rewrite it up here. 6x minus 7y equals 3, and 30x minus 35y equals 6. And that bracket there says that this is a system. We want a value for x and y that makes both equations true. Now, the way the addition method works is we either want to get the x's to cancel each other, in other words, have opposite coefficients, the same number but one positive and one negative, or get the y's to cancel. So I'm going to make an executive decision here, and I'm going to try to eliminate the x's. This is a positive 30x. I want this to become a negative 30x, because then a negative and a positive would cancel each other. What do I have to multiply 6 by to get negative 30? I have to multiply it by negative 5. And I can multiply an equation by a constant as long as I remember to multiply everything inside the parens. So, negative 5 times 6x is negative 30x. Negative 5 times negative 7y, negative times a negative is positive. Bring my equals, and here's the most common mistake in this type of problem. People forget to multiply the right-hand side of the equal sign by negative 5 too. Here we have negative 5 times 3 is negative 15. And now let's write our second equation. I've not done anything to the second equation. I've just rewritten an equivalent equation for the first equation. And now I want to draw a line and add down. Negative 30x and positive 30x, they're going to cancel. And as it turns out, positive 35y and negative 35y is also 0. Bring down your equal sign. And negative 15 plus 6, opposite signs you subtract, and keep the sign of the greater. So I get x equals negative 9. When will x equal negative 9? Never. I'm putting a slash through that. This is a contradiction. When you're trying to solve a system, and if you come up with a contradiction, what that means is there's no possible xy value that will ever make both equations true at the same time. So my correct answer is no solution. My correct answer is no solution. There's no possible value of x and y that would ever make both equations true. And what that tells me is that these are parallel lines. If I were to graph both of these lines, they would be parallel lines. They would never meet. There would be no point of intersection. They have the same slope. They're both going up and over, up and over, up and over at the same rate. So if I want to check my work, I want to find the slope of each of these lines and see if they have the same slope. Here we have 6x minus 7y equals 3. And here we have 30x minus 35y equals 6. If I want to find the slope, I have to get y by itself. So let's subtract 6x from both sides, and we get negative 7y equals negative 6x plus 3. And I want to get the y by itself, so I'm going to divide by negative 7. Which means I have to divide all my terms by negative 7. So in slope-intercept form, the equation of this line is y equals 6/7 x minus 3/7. This tells me the slope is up 6 over 7, up 6 over 7, up 6 over 7, up 6 over 7, up 6 over 7. That's the slope of this first line. Let's come on over here and find the slope of the second line. Let's subtract 30x from both sides. Negative 35y equals negative 30x plus 6. And in order to be able to get the slope, I have to have y by itself. So divide everything by negative 35. And I'm left with y equals, negative divided by negative is positive, 30 over 35x minus 6 over 35. Well, you know what? 30 over 35 is not in reduced form. 5 goes into both the numerator and denominator. 5 goes into 36 times, 5 goes into 35. 7 times minus 6 over 35. So the slope of this line is also 6/7. So this line is going up 6 over 7, up 6 over 7. So you know what? These two lines have the same slope. This one crosses the y-axis at negative 3/7. This one crosses the y-axis at negative 6/35. But they're both going up 6 over 7, up 6 over 7, up 6 over 7. They will always be parallel to each other, and they will never intersect. And what does that mean to us? That means there's no point of intersection. It means this system has no solution. All right, so that's the second page of that test. All right, here we have a division problem of polynomials, and they want us to divide without using long division. So since there's just a single term in the denominator, let me go ahead and rewrite this. 6x to the 7th minus 12x to the 3rd over negative 2x to the 7th. I can rewrite this as two fractions. 6x to the 7th over negative 2x to the 7th. And here's my minus 12x to the 3rd over negative 2x to the 7th. So rather than 2 terms in my numerator, I actually have 2 fractions now. So now I'm going to reduce each fraction individually. 6 divided by -2 is -3. And x to the 7th and x to the 7th will cancel each other. There's an x to the 7th in the numerator and an x to the 7th in the denominator. So they cancel each other. Okay, now bring down the minus. And now I'm going to simplify that fraction. 12 divided by -2 is -6. And x to the 3rd divided by x to the 7th. When you have like bases and you're dividing, you subtract the exponents. So this is going to be x to the 3 minus 7. You actually did this here too. This is x to the 7 minus 7, which would have been 0. And anything to the 0 power is 1. But this is going to be x to the -4th. Now, is the 6 being raised to the -4th? No, it is not, just the x. And we know a negative of a negative, or negative times negative, is positive. So my answer is -3 plus 6 over x to the 4th. That's polynomial division by breaking the numerator up into 2 terms. Okay, we're going to keep moving. Number 7 is polynomial multiplication. This is 4z plus 3 squared. That means 4z plus 3 multiplied by itself twice. And so now we're going to have a binomial. Binomials multiply by themselves. So we're going to do a first, an outside, an inside, and a last, the FOIL notation. 4z times 4z is 16z squared. Now the outside, 4z times a positive 3 is positive 12z. Now we're going to do the inside 2 terms. 3 times 4z is positive 12z. And now we're going to do our last terms. 3 times 3 is a positive 9. And then I do want to combine my like terms here. So my final answer is 16z squared plus 24z plus 9.